Everyone, in this video, we're going to be looking at graphing absolute value linear functions, and specifically some tricky cases where we've got to do a little bit of algebra to figure out what some of our features are. So oftentimes to trip students up, I'll put another coefficient onto the x in addition to the coefficient in front of the absolute value sign. And in order to get through that, what you need to do is you actually need to factor out whatever that coefficient is out of the stuff that's in the brackets. So, or in the absolute value signs, I should say. And so that works out to being x minus p over b, whatever b is. And so sometimes this doesn't evaluate to a whole number. Sometimes it'll be some fraction. And it's fine. It just means that your vertex is at that point on the x axis, and it's like just at some fractional or some fraction value. Now you can actually factor b completely out of the absolute value signs and just know that your slope is whatever the coefficient of a is times whatever your slope is whatever a is times b. Those are both coefficients. Anyways, yeah, so that's the best way to do a lot of this stuff is just with an example. So here, again, I would have a lot of students right off the bat saying the vertex is -8, -3. Well, that's not correct because I've got this I've got this 2 right here, which means I need to factor it out. So I'm just going to do a little bit of legwork here. I'm going to call this 1/2, and then I'll say 2x plus 4, close my brackets, and then -3. So my vertex is actually at -4, -3. Now, I can take the 2 fully out of the absolute value signs. I can literally just call this y is equal to x plus 4 and then -3. And the reason I can do that is because the 2 times 1/2 is just going to give me 1. So it's like I got a coefficient of 1 right there, and I don't have to bother writing that. So I'm just going to go through the rest of the stuff quickly. So my domain is x is real. My range, it looks like I'm going to be opening upward. So my range is y is greater than or equal to -3. Y is real. Axis of symmetry, x is equal to -4. Direction of opening is upwards. And the slopes are going to be plus or minus 1. So to find, and I'll graph it first. So -4, -3. So -4, and then -3 is approximately right there. And I've got a slope of 1/1, so something like that. So the function looks like this. So let's come down here, and then I can just solve for this algebraically here. So I'm going to go for a y-intercept. I'll make x equal to 0. So I'll say y is equal to absolute value 0 plus 4, absolute value -3, or 4 minus 3, and that's just equal to 1. And I can see here that trend, I can just tell just by the way I sketched it, it looks like it will be crossing at 1 there. So my, y-intercept is 0, 1. To find my x-intercepts, and I can see just by looking at it, there's going to be 2. So to find my x-intercepts, I'm going to make y equal to 0. And then I'll say 0, I'm just going to do my work over here. 0 is equal to x plus 4, close my absolute value sign, at -3. I'll add 3 to both sides. So 3 is equal to x plus 4. And again, I've got that situation there where the 3 could be plus or minus. I'm not sure what it is. So I'm going to write it as x is equal to plus or minus 3. And then I'm going to subtract 4 from both sides, and then minus 4. And this is still under absolute value signs there. So this is then going to evaluate 2, if I just want to show where it goes. So 3 minus 4 is -1. -3 minus 4 is -7. There we go, I can do math. So my 2 x-intercepts then are going to be -1, 0 and -7, 0. And so I can see just approximately that looks right and that looks right. It's looking good. So let's do another one. Oh, there was only one. So that's going to be it for this video. And if you're having questions, come find me in class.